Welcome to Stats with Chaz. I'm Dr. Charlie Collins. Today I will discuss dispersion in statistics. We will cover what dispersion is and when to use it, and how to calculate measures of dispersion. Measures of dispersion are an additional way to describe data. Central tendency, discussed in my previous video, describes the central or typical score in a distribution of scores. Dispersion, on the other hand, describes the variety and diversity of scores. In other words, dispersion describes the relative consistency of scores. It's pretty reasonable to want to understand central tendency, but why would I want to understand dispersion? Let me use an example of investments. Let's say I want to invest in my retirement and I'm choosing between two investing agents. Because this is a long-term investment, I really want consistency in the return on my investment. Both agents have the same average percentage on their returns, let's say about 5%. The returns provided in the first agent all hover around 5%, some slightly less, some slightly more. The second agent's returns vary considerably more, having returns in the much higher and lower ends of the distribution. Dispersion can help me figure this out. I'd likely want to go with the first agent since his returns on investment are much more consistent. So how do we measure dispersion? There are several measures including range, interquartile range, variance, and standard deviation. Each of these measures of dispersion should primarily be used on interval ratio variables or when you can also calculate the mean. Today I will only discuss the range, variance, and standard deviation. The range is defined as the distance between the highest and lowest scores. Although easy to calculate and understand, it is sensitive to outliers that can dramatically change the statistic. Both variance and standard deviation measures use all scores in the distribution. Both measures can be thought of as the average distance of scores from the mean. As they get larger, we know our scores are becoming more diverse. Let's jump into calculating range, variance, and standard deviation. For our example, I will use entering GPAs for freshmen for all Washington State public universities. Let's take a look at our scores. As you can see here, we have our average entering class GPAs, or average GPA for incoming freshmen, for each of the Washington public universities: Central Eastern, Evergreen, UW Seattle, UW Bothell, UW Tacoma, Wazoo, and Western Washington. We want to know the range, variance, and standard deviation for this distribution of scores. The range is the easiest. It's the largest score minus the smallest score. In this case, we find that UW Seattle has a score of 3.76 minus the smallest score of Evergreen, which is 3.01. And that gives us a range score of 0.75. So we can interpret this as the range is 0.75, or another way to put it is our data set, our range is between 3.76 and 3.01. Both ways to report are valid. Variance and standard deviation are a bit more complex, as you can see from the formulas. The only difference between the two is that you take the square root from the standard deviation and you don't from the variance. First, we find the mean. I did this earlier and found that the mean is 3.34. Next, we have to calculate the deviations, and this is the deviation column. The deviation is each score minus the mean. So this xi here represents each score. So for example, 3.49 would be x sub 1, this would be x sub 2, this x sub I, the I is simply representing each of these potential scores, or each of these potential cases, I should say. So I'll do this for Central Washington. So what we have here is we have our x score, which is 3.49, minus our 3.34, and what that gives us is 0.15. All right? So I'm going to do that for each one, and I already have it laid out in an Excel file, so I'm just going to write them down so you can follow along and do the math yourself if you'd like. Next, what we need to do is we need to square the deviation scores for each case. So I'll do that for Central Washington. So we have 0.15 squared gives us 0.02. And we have to do that for each case. So 0.15, negative 0.10, negative 0.33, and so on. We square each of these and we put them into this column that's called the squared deviation scores, or the deviation score squared. So I'll go ahead and do that and just write these numbers down, and you can try to follow along. Also keep note that there is some rounding going on here. So Excel calculated these for me, so if your rounding is slightly different, that's okay. Just make sure you're close to this and close to these numbers. So I'll go ahead and add all these up. Next, what we have to do is we have to sum the squared deviation scores. So what we need to do is take all of these scores and add them together. That's what summing means. Again, I've done this previously, so what I have here is 0.34. That is our summed deviation scores. Then to move on to calculate variance and standard deviation, what we need to do is divide this number, our sum of the squared deviation scores, and divide that by our sample size. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 different cases. So we divide 0.34 by 8, and that gives us 0.042. And obviously you're going to want more space than I have here. And the interesting thing is this 0.042 is the variance. So if you're only calculating variance, you don't need to go any further. If you want to calculate standard deviation, we have to take this 0.042 and take the square root of it. And what that does is it gives us 0.205. So hopefully if you calculated this all out with me, you should have 0.205 as your final answer for your standard deviation. I do want to take a quick note that I'm using the calculation for the whole population and not for a sample, and we'll talk about that later and throughout this series. So after all of these calculations, what we're finding here is the average distance from the mean for these colleges is 0.205, which is fairly small. This means that the diversity of incoming GPAs between these universities is fairly small. By now you should know what dispersion is and when to use it, and how to calculate measures of dispersion. Thanks for watching Stats with Chaz. I'm Dr. Charlie Collins.